Hello everyone, my name's Alex Donner and today I will be guiding you through HyperMesh and teaching you how to use it to make things like nodes, lines, planes, and geometries, how to make beam elements with voids in them, how to use Boolean to combine two solids, and finally how to apply pressures to beam elements. The first thing we're going to do is select OptiStruct for our user interface. Now we're going to be going to Geometry, then selecting the Nodes card. The first thing we're going to do is create nodes on our model space. So the first one's going to be at our origin 0, 0, 0. We're going to put 0 for the X, Y, and Z components. Then click Create. So after you click Create, you can see the node is now there. If you click F on your keyboard, it'll automatically fit your complete model to your screen. So now we're going to stay in X equals 0. We're going to put Y equals 10. That will create the next node. And now Z equals 10, Y equals 0, and Z equals 10. So this creates a perfect square, which will be the cross-section of our beam. And it's also to point out that these nodes don't have any dimensions, they're just simply points on our model space that we can use to make lines and planes. From here, we're going to be using the nodes to create planes. So if you go to 2D, then go to planes, we're going to select nodes. So in this box, we're going to be selecting what we're going to be using to make the planes. So we're going to select our nodes all, surface only, click create, and this will make the plane between all 4 of our nodes. If you click the view button, it'll show you that it's now a solid plane. Click return. We're now going to export this plane into a solid. So geometry solids, we're going to click the extrude along an axis, drag along vector, which is the same thing as dragging along an axis. So drag along vector, you can see there's 3 different options, but for today we're going to drag it along the vector. Now we're going to make sure surfs are selected. You can either select all or you can just select the surface that we made, which we'll do. Now pick the axis you want to extrude it on. Today it's going to be the x-axis and then the distance or the length of the beam. Click drag plus or drag minus for the direction along the axis, but we're going to drag it along the positive axis for this model. So if you click F, you can see now the full model extruded along the x-axis. Now this model is solid. That's what the green outline indicates. And it's been extruded a distance of 75. And this is a unitless distance. It can be inputted later on. So we're going to click return. You can see it's now a solid. So this is it for the solids tutorial. We're going to delete this model and now work on creating a different model with voids. So if you click the delete button, you can click delete model and it'll delete everything in your model space. So now we're going to go back to nodes and create a new set of nodes to create our new beam. So we're going to start again at the origin. It's going to be our first corner. Except now, instead of drawing the nodes for the cross section, we're going to draw the nodes for the side of the beam. So we're going to draw another node at z equals 10. And now for z equals 5. So for this one, for our void spaces, we're going to have 3 nodes because we're going to end up interpolating nodes across the beam to create circles. So now we're at x equals 75, aka the distance or the length of the beam. And we're going to create our 3 nodes at x equals 75 that we're going to be connecting to our first 3 nodes at the beginning of the beam. So if you click F, your model should look like this. Now if you stay on the nodes page, we're going to click the interpolate nodes. And this function is going to give us nodes in between 2 different nodes. So select the 2 nodes you want to add nodes in between. We're going to add 5 and click create. and that you see 5 nodes have just been created between the 2 nodes we selected. So now we're going to go to lines, and we're going to outline the side of our beam by making sure node list is selected, selecting the 2 nodes you want the line to be between, and then clicking your scroll button on your mouse or create to create the actual line. So now our outline is made. We're now going to go to the circle button so we can make the circular outlines of our voids. So you can select the nodes by making a window, or you can select them individually. Both of these options will work, but I will show you the window option. Make sure interior is selected and select the nodes. Now you pick your radius for your openings. We'll pick 1.5 along your y-axis. This means the center will be along the y-axis. Click create, and now your circles are made in the ZX plane. So if you click the view button, you see we haven't made it a surface yet, it's still just lines. So we'll go to 2D, planes. Now we're going to make sure lines are selected. If you click lines, you have the option of selecting all of them, which we will do. Now make sure surface only is selected, we don't want to mesh yet, and click create. And now you'll have that surface with those circular voids. So now we're going to create the solid part of this surface. So you're going to go to Geometry, Solids, Drag Along Vector, make sure Surface is selected, select your surface. Now we're going to extrude it along the y-axis this time on a distance of 2. So this will create a thickness in our beam of 2, and you'll see the circular voids we made are still in place. So we just extruded that surface along the y-axis to create the thickness of our beam. Okay. So now we're going to create the top T of our T-beam. So we created the side, now we're going to create the rest of our cross-section. So we're going to start at x is 0, or we can start at x is 75 across the beam, just to show you that you can also drag the solid in the negative x or x-axis. So we're going to start at x is 75, y is -1, and z is 10. Excuse me, messed up. Z should be 11. So now we're just creating the 4 nodes we're going to be using to create the upper rectangle. It should be noted that the reason we're picking Z is 10 for 2 of these nodes is because the edge of this top rectangle has to be the same or share an edge as the bottom rectangle. So if we look at it from the front view, the 2 nodes in the bottom left and right hand corners are along the same line as the nodes in the first piece we made. So now we're going to go to 2D planes and create the plane for the top part of our cross section. Select the 4 nodes, surface only, create. And now you'll see we created the top plane, which we can now extrude into a solid. So go to Geometry, Solids. We're going to make sure we're dragging along the vector. Surfs are selected, and now we're going to drag it along the x-axis for a distance of 75, the same as our last piece. So we're going to click our surface, and now we drag it along the negative direction of our x-axis, because if you can see at the bottom left-hand corner, positive x-axis is pointing to the right. So we want it to be extruded along the left. So now we have these 2 solid pieces, which we need to make 1 solid piece before we can do an analysis or an optimization. So we're going to go to Geometry, Edit Solids. You can see they're 2 separate pieces because they're glowing separately, and you select them. So you go to Solid Edit Boolean, Make your orientation type simple. Operation A plus B is a union of two solids. So if you click them and click calculate, they'll now be recognized as one singular solid. If you reject this, you can also see that these two solids can be combined only at their surfaces, but still be two separate pieces. So if you go to advanced, combine through none, and do A plus B, calculate, that yellow element that is made, that just denotes that the two solid pieces are now connected by that surface. But we're going to do a simple union to make it one solid piece. So now if you go to 3D Tetramesh, we're going to mesh this element. So make sure solids is selected. Your 2D type, we're going to use mixed. 3D type, tetras, and this is just the shape of the mesh. Element size is usually 2. If you click mesh, our piece is now meshed into smaller areas that are going to be more precise when we optimize and analyze this piece. As you can see, they were meshed together because of the Boolean function. So now the last thing to do is we're going to be doing a load collector so we can apply the pressure force. So if you go to load collector, name it force, click create, we now have that force created under our load collectors. We're going to go to analysis, pressures. Here we're going to go to create to create a new pressure. Make sure your force is made current on your load collector. Now we're going to go by surfaces. So this pressure is going to act on the full surface of whatever surface we select. So relative size, we're going to make it a little bigger. Since 1.316 is a pretty small number, we're going to make it 200, and then in magnitude, we're going to do 1.316. And then select the surface and create. So you can see the 1.316 load is now applied, but when we run the analysis, that arrow will be applied to each individual element. So you can see the OptiStruct doesn't work yet because you don't have your constraints or your materials. So I will do that off to the side and then show, once the analysis is run, how the arrows are extended to each of the elements on the surface. Alright, so as you can see, I've created the load collectors and the materials and the properties. So now when we run the OptiStruct analysis, each of those arrows is multiplied by the elements and applied to each one. This is the end of the tutorial. I hope I was some help in HyperMesh, and thank you for watching.